Be number 11. I already chose the left side. Again, you could choose the right side. Your proof would look almost exactly like mine, except it would be going backwards. And again, there's a couple different ways you can do these proofs. This one especially. So I'm going to want things in terms of sine and cosine at some point. Because right now I got tangent and secant. So my one thing I always try first is I look for Pythagorean identities. The main thing that's going to tell you there's a Pythagorean identity is if you have something squared, and we do. So remember, off to the side, it's helpful to write these on your paper. Here's my main one. Sine squared plus cosine squared equals 1. From that I can get 1 plus cotangent squared equals cosecant squared. I can also get tangent squared plus 1 equals secant squared. Alright, so if I have tangent squared on top, well, here's tangent. If I minus 1 to each side, tangent squared would be equal to secant squared minus 1. So I'm going to rewrite that. Again, I said tangent squared is equal to secant squared minus 1, and then it's going to be all over secant of x plus 1. So, now, again, this way, there's two different routes we could go. We could do difference of squares on top and factor that out. Or we could put everything in terms of sine and cosine first. I just feel like, and I don't know if it's going to work, it might not, but I feel like factoring it out because I like to factor. But I won't because most of you don't see difference of squares. If I were to do difference of squares, it'd be secant of x minus 1, secant of x plus 1. But a lot of you don't see that, so you'd get stuck here. So I'll do what most of you would do, I think. Most of you would rewrite this in terms of sine and cosine. Well, remember, secant is 1 over cosine, so this would be 1 over cosine squared x minus 1. All of that over secant is 1 over cosine of x, and then plus 1. I think most of you would get to this step. I don't think you would notice difference of squares. You could do difference of squares, but we'll do this. Then I got fraction over fraction. That's gross. So I want to cancel that fraction out. Remember, to cancel this out, I'd have to times it by cosine squared. So I'm going to take the entire top and times it by cosine squared of x. Can't just times the top by cosine squared because that would change it. I also have to times the bottom by cosine squared. Because cosine squared divided by cosine squared is 1. So then, now that I have that, cosine squared times cosine squared is 1. And then I get minus, this times 1 is cosine squared. Then cosine squared x times cosine of x. Well, I know that is equal to cosine squared x. And then I get 1 times cosine, which is plus cosine squared of x. That doesn't look like a plus sign. It looks like a blob. I'm sorry. So again, I just foiled that. Then the top now, yes, this is sine squared, but I don't want sine squared. I want 1 minus cosine. So now you would have to see that this can be rewritten as a difference of squares. So I could go 1 minus cosine of x times 1 plus cosine of x. Remember, these are conjugates of each other, so when you FOIL them out, the middle term would cancel. And then, I know I want cosine on the bottom. Well, this should not be squared. Oops, that should just be cosine, because cosine squared x times cosine is cosine of x. I'm going to factor out a cosine from this, because I know I'm going to want a cosine just by itself from my original problem. So if I factor out a cosine on the bottom, I'd get cosine of x, 1 plus cosine of x. Then these factor out or divide out and cancel out, and then I end up getting 1 minus cosine of x over cosine of x, which is where I wanted to end. So that is proof of 11. Now, I'm going to redo this one so you can kind of see from this step. So from that step, you could have also, I'm going to show you that there's multiple ways to do this. So again, I would have done all the same steps until I got to here. Now, if you notice that there is difference of squares, and this could be difference of squares, and you could have written this as secant of x plus 1, secant of x minus 1 over secant of x plus 1, then these would divide out. You'd be left with secant of x minus 1. Okay. We could rewrite that as 1 over cosine of x minus 1. Now, I want a common denominator, so I'm going to times 1 by cosine of x over cosine of x. So I get 1 minus cosine of x minus cosine of x over cosine of x. Alright, they have the same denominator, so now I can combine them. 1 minus cosine of x over cosine of x. Get the same thing, and it's in a lot less steps, and I think the algebra is easier. But again, the purpose of doing this was to see, hey, if you see difference of squares, it makes it easier. But if you don't, and put it in terms of sine and cosine, you can still do that, it just takes longer. So again, there's two different ways to do this proof right there. Now, let's go into number 12. If we're looking at this, number 12, I'm taking two things, I'm subtracting them, and then I want to have one giant thing. So, pick your side. I'm going to do the subtraction sign. You could try to put things all in terms of sine and cosine. You could do difference of squares. There's a bunch of different things you could do. I'm going to put things in terms of sine and cosine. Try it. If it doesn't work, I could try difference of squares. If that doesn't work, you're kind of out of luck. So, I'm going to start with rewriting cotangent. Remember, cotangent squared can be rewritten as cosine squared of x over sine squared of x. Then I have minus cosine squared of x. Now, I have a fraction minus a constant. So I want to times this. I want to get a common denominator. So sine squared, sine squared. So we're just manipulating. The reason I can times just that by this is because this is equal to 1. So then I'm left with what I originally had, cosine squared over sine squared, minus cosine squared, sine squared, I don't know what that is, so cosine squared x, sine squared x, over sine squared. Now, since they have the same bottom and they're fractions, I can now just subtract. So I get cosine squared x minus cosine squared x, sine squared x, all over sine squared x. Whew. Okay. Now, I know I'm going to want a cosine squared, and I know I'm going to want a cotangent. The only thing I have left to do is, hey, there's a cosine squared here, and there's a cosine squared here. So I'm going to factor out a cosine squared. When I do that, I get 1, and then minus sine squared of x. So I just factored out that cosine squared over sine squared. Well, I know I wanted cotangent. Well, I already kind of technically have that using my quotient. Cosine divided by sine, that is equal to cotangent squared. And then I have 1 minus sine squared. Again, I have a 1 minus sine squared using my original cosine squared plus sine squared equals 1. I could rewrite that by subtracting. So this, from that Pythagorean identity that you should probably write on the top of your papers every time, I know that's equal to, I can rewrite that as cosine squared. And then the order we multiply in doesn't matter, so you could rewrite it so it matches if you wanted, or you could just call it done. We got to where we needed to be, so we'd put a box. So that's how you would do number 12.